This question says 6.9 grams of potassium carbonate has been converted into this complex compound after treating with a series of reagents, and we do not know what those reagents are. And if all the carbon in potassium carbonate is converted into potassium zinc ferrocyanide, that is this complex compound, calculate the mass of that complex compound. See, we do not know in how many steps the carbon present in this potassium carbonate is converted into this complex compound. Also, we do not know all the reactants and products involved in each step. Therefore, we cannot write balanced chemical equations. Now, if you cannot write balanced chemical equations, how do you answer this question? There is a clue in the question. It says all the carbon in the potassium carbonate we took is converted into this complex compound. We will answer this question using this clue. Now from the question we understand that we started with 6.9 grams of potassium carbonate, and eventually all the carbon present in this potassium carbonate has been converted into this complex compound. That means all the carbon present in 6.9 grams of potassium carbonate ended up in this complex compound. It did not go anywhere else. And we have to find out the mass of this complex compound. Let us say its mass is x grams. Now here I have written an equation that shows only the reactant and the product that we are interested in to answer this question. So this is not a complete chemical equation. Now the second point is this is not balanced. We have not yet applied the law of conservation of mass to this equation. See, if you do not see any number before a symbol or a formula, there is an implied 1. So there is a 1 here and there is a 1 here as well. By looking at these numbers, don't try to interpret a relationship between these quantities. You cannot say that 1 mole of potassium carbonate produces 1 mole of this complex compound, because this equation is not balanced. You can interpret such a relationship with the coefficients found in a balanced chemical equation. Because this is not balanced, don't try to interpret a relationship between these coefficients. So this is neither a complete chemical equation nor it is balanced. It only shows the reactant and the product that we are interested in to answer this question. So as we understand from the question, all the carbon present in 6.9 grams of this compound ended up in this compound. It did not go anywhere else. So that simply means by applying law of conservation of mass, mass of carbon in 6.9 grams of potassium carbonate is equal to the mass of carbon in x grams of this complex compound, right? Because the question says all the carbon present in the potassium carbonate that we took ended up in this compound. Now if the mass of carbon is same on both sides, then the number of carbon atoms must also be the same, right? So the number of carbon atoms in 6.9 grams of potassium carbonate must be equal to the number of carbon atoms in x grams of this complex compound. Now, how do we get the number of carbon atoms in 6.9 grams of potassium carbonate? Now, if you divide the given mass with the formula weight of this compound expressed in grams, you will get the number of moles of that compound. The formula weight of potassium carbonate is approximately 138, and you know how to figure that out. So if you divide it with 138.0 grams, you would get the number of moles of potassium carbonate. And if you multiply the number of moles with Avogadro's number, you would get the number of formula units of potassium carbonate. It is an ionic compound. So K2CO3 represents one formula unit. So number of moles multiplied with Avogadro's number gives the number of formula units present in 6.9 grams of potassium carbonate. Now in each formula unit there is one carbon atom. So if you have so many formula units with each formula unit containing one carbon atom, to get the total number of carbon atoms, you have to multiply this whole thing with 1. So this is the expression for the total number of carbon atoms present in 6.9 grams of potassium carbonate. Now, how do we get the number of carbon atoms in x grams of this complex compound? Again, if you divide the given mass with the formula weight of this compound expressed in grams, the formula weight of this compound comes to be around 698 approximately. So if you divide it with 698.0 grams, you would get the number of moles of this complex compound. And if you multiply the number of moles with Avogadro's number, you would get the number of formula units of this complex compound. Again, this is an ionic compound. And to get the number of carbon atoms, you know that in each formula unit there are 6 times 2, 12 carbon atoms. So if you have so many formula units with each formula unit containing 12 carbon atoms, the total number of carbon atoms would be the number of formula units multiplied with 12. Now you solve this to get the value of x and express that in grams to answer this question. That would be the mass of the complex compound formed. See, again, we are able to answer this question without needing a balanced chemical equation. We applied law of conservation of mass to the element carbon because in the question it is given that all the carbon present in the sample of potassium carbonate that we took got converted into this complex compound. And from law of conservation of mass, we applied the principle of atom conservation, because if mass of a given element is conserved, then the number of atoms of that element must also be conserved. And from that we derived expressions to get the number of atoms on both sides, and you know how to simplify this to get the answer.